Hello, my friends. Nice to meet you again. On a 4x4 grid, there is a sun, a moon, and 14 stars. Their positions are randomly placed. But the positions of the sun and moon are always next to each other. Now let's reposition them again, and cover them with 16 covers. In this case, at least how many covers need to be removed, so that one can guarantee that the sun and moon are both exposed? Why not give a try, and we will come back soon. The two key words in the question are, at least, and, guarantee. At least demands the most optimal strategy, and guarantee means that we need to consider the most unlucky case. That is, even with the most optimal strategy, the stars are always exposed first. Then the goal is of course to identify as many stars as possible, which are behind the unremoved covers, every time before removing the next one. How to do that? The clearest information in this question is that the sun and moon are next to each other. That is, all those cells whose neighbor cells are all stars must be placed with stars as well. So, how can we identify as many cells as possible, whose covers haven't been removed, and whose neighbors are all stars? In general, there are two possibilities. One is to remove the covers behind the red points, and the other is to remove the covers behind the blue points. In fact, these two possibilities are symmetrical. So we only need to discuss one of them. Even though the covers to be removed are known, the order of removing them is still an important issue. For example, if we do it in this order. In the most unlucky case, after removing the seventh cover, we still haven't seen the sun or the moon. So how many stars can we identify right now? That's right. The cells whose covers are removed, as well as the cells whose neighbors' covers are all removed. At this time, there are still 5 cells that have not been identified. Since the sun and the moon are always next to each other, there can be 1, 2, 3, 4. A total of 4 possibilities. The center position must be either the sun or the moon. In the most unlucky case, we still need 4 more tries to find the other one. So it takes a total of 12 times to expose both the sun and the moon. Is it possible to take fewer times? The answer is yes. Let's first take a look at why we try so many times in this situation. This is because the cell behind the last blue point has too many neighbors. This leaves too many possibilities for the positions of the sun and moon. Therefore, a more optimized strategy should be to start from the cells with more neighbors, and then to the cells with fewer neighbors when removing the covers behind the blue points. So a better order should be like this. Now, in the most unlucky case, the sun or moon has not been found after opening the 7th cell. But there are more stars' positions that can be determined. Then only 2 possibilities for the positions of the sun and the moon. The cell behind the 8th blue point must be either the sun or the moon. In the unlucky case, it only takes 10 times to expose both of them. Some friends may ask, if one of the sun or moon has been already found at a previous step, will it take more steps to find the other one? The answer is no. Because if one of the sun or moon is found at any previous step, the total number of steps required is equal to the number of steps, plus the number of neighbors of that cell. For example, if it is found at the 7th step, the cell has only 2 neighbors. So the final number of steps is 7 plus 2, which equals 9. If at step 6, the cell has 3 neighbors, 6 plus 3 is also 9. If it is at the 2nd step, whose cell has the most neighbors, but still only 4 neighbors, so the final number is just 2 plus 4, which equals 6. Therefore, with this strategy, we only need to remove maximum 10 covers to expose both the sun and the moon. Thank you for watching, and see you next time.